Hi all, in this video we are going to see about the text classification using Naïve classifier. So when you look at the textual data, you have the textual data with corresponding, after pre-processing and everything, say you have the tags associated with it and everything. So your main job next is to extract the features, right? So you need to perform a feature extraction. So you will collect all the features, and then upon that those features which you have already identified, you will apply the machine learning algorithm and you will perform the text classification. So this is just a very generic way of showing what it is, but I felt like it is a good one. And now today in this class we are going to talk about the Naïve classifier, and that too we are actually going to do a text classification by using the Naïve classifier. Okay, so here for that we are basically using this text blob. So text blob is a Python library, okay, and it's a Python library specifically for the textual data, and say it provides some API for diving into common natural language processing. That's why we are using it. Say speech of parts of the speech, tagging, non-phrase extraction, etc., sentiment analysis, classification, etc. But here our main concentration is upon classification of the data. Okay, so here if you look at it, so this is the text blob. So from text blob import text blob, and text blob classifiers import the Naïve classifier. That means that you have this Naïve classifier available from within the text blob dot classifiers. Okay, so this is also one of the classifiers in this particular text blob package. Now we will see a simple data set. So when you look at the data set here, it is a labeled data set. What do you mean by a labeled data set? Say whenever you are doing a supervised learning, so in the data set you will have the data which is given along with the labels. Say I love my country, and it is actually positive, and you could say that I did not like the smell of this place, which is actually given as negative. So this positive and negative which you could see are basically the labels associated with it. And again when you look at it, we are actually using the Punket package. Okay, so this is mainly for pre-processing and all the stuff, right, and also for tokenizing our data. And now we are actually applying the model. So if you look at here, it's as simple as that. So you have your data, okay, you have the data, this is your data which is actually there, right, and you are just applying, you are just calling the model Naïve classifier upon the data, and you are actually saving it into a model. Okay, and you are actually testing that particular model. You are asking that model to classify by giving one of the sentences, right? So what is the sentence which is actually given here? It's not the sentence which is already there in here. Okay, so this is a test sentence. Okay, so when you look at here and when you give this particular thing, it will show you it is positive or negative. Say I will run this code now. So it might take some time because I randomly I suddenly pressed it, that's why. So it will take some time, so wait, I'll just show you. So when you look at it, you will get this answer as the positive comment, right? Say if I am calling again, say I'm just copying this code and I'm just trying to classify. What a dirty place. See, when you look at it, you would have got this, this is the final one. I mean, like this is the final one which you are actually getting. So when you run this, you will get this, and you can use this code. It is actually showing negative. So this is how actually you will use this Naïve classifier. So the Naïve classifier from the text blob, this is very easy for you to use. Okay, so try this and try to get a data from somewhere, import a data from a data set and try using it. So in this example we are going to see about multinomial Naïve classifier. So there is a classifier, actually it's kind of the Naïve algorithm itself, but it is actually multinomial. So when you look at it, it is again a probabilistic kind of a method. Okay, so and this is actually based on the Bayes theorem itself, whatever we have seen. but it will predict the tag of the text such as a piece of newspaper, etc. Okay, so it calculates the probability of tag for a given sample and then gives the tag with the highest probability as output, right? So the presence or absence of a feature does not affect the presence or absence of other feature. That's the beauty of this particular multinomial Bayes algorithm. Okay, so here we are actually giving all these packages. We are using the sklearn, and we are also using NLTK, and we are importing the NLTK. And here you could see that we are ignoring all the warnings, but still, just for you to understand that what kind of an error is this egg info. So this setup egg info is basically the information about the packages. Okay, so egg info basically contains a package metadata. Metadata you all know, right? Metadata is actually data about the data, but here it is a data about the data, but of regarding the package. Okay, so it will have the complete details about the package, its name, version, dependencies, and all those information will be available, right? So here in this data, if you look at it, so you are actually loading the data. Okay, and for that basically we are actually using 20 news group data, and we are actually fetching this particular data directly from the sklearn datasets. This means that sklearn is a big library which has got a lot of datasets, right? So in that you have this dataset called fetch 20 news groups. That means that it has the data of 20 different news groups and information is already there. Okay, so there are certain categories, and it's about the information about the news is there. So we are actually taking those data into the news groups underscore data, and you are actually taking it as a subset for the train, and x and y, the news group data is basically dot data and the dot target. You are actually splitting your data into target and this thing. So that is what actually you are doing here. Then you have to pre-process the data. For pre-processing the data, you are importing all the libraries which is required. So mainly tokenizing, stopword removal, and Porter stemma. And for tokenizing you need Punkat, so you are actually doing that. For stopwords you need the stopwords, so you are actually for stopwords, and stopwords is mainly used for stemming, right? So for that we require that. Now how are we actually pre-processing the data? We are actually tokenizing the text. We are actually taking all the stopwords into this this stopwords, and then we have to filter the tokens. So how are we actually filtering the tokens? We are first filtering by using removing all the lowercase, then is alpha, and everything, right? So these are the things which are actually, this is a kind of the regular expression which is followed. Then we are actually applying it upon the Porter stemma. So Porter stemma is now in the stemma. Now what you are going to do is that you are applying that upon the filtered tokens. For each token and the filter token you have to apply the Porter stemma. Okay, so and then you have to join them by using the space, and yeah, so this is how actually you will do it. And so for pre-processing, basically what you have to do is that you have to pre-process text and of the text, right? So for text in x, like whatever b is there in the x, you have to actually so x is nothing but whatever is actually passed. Now we need to transform the data into numerical features. So how could we do it? We already know that there are different ways for doing it. Either we can use TF-IDF, or we can use TF-IDF vectorizer class and everything. So here we are trying to use a TF-IDF vectorizer class, so that it will make our life easier. So again in sklearn we do have this curve called sklearn.feature underscore extraction text. Okay, so in that you have this TF-IDF vectorizer. So you are just using that vectorizer, and then you are actually applying it. So that's why fit underscore transform means you are applying it upon the x processed. Okay, and then now what we have to do is that now we have to train the next text classification model. Okay, so for that we are basically using this multinomial Naïve theorem. Okay, so again multinomial is as we have seen, the Naïve is already there in the sklearn. Multinomial NB is also there in the sklearn.Naïve import. Okay, so we are actually putting that in the classifier. Then we are actually classifier.fit. So this is like applying the model upon the x transformed. Where did you get the x transformed? You are actually getting the x transformed from here, right? So x transformed comma y, right? Now we have to evaluate the classification model. Once we have to evaluate the classification problem, these are the basic steps which we have to follow. So in this we are just going to evaluate the text classification model. So for that, we have already taken the test from the, so this is actually the subset of the 20 news groups data itself. So in that, we are just taking this as our test data, and then we are making it into X test and Y test. Then we are actually taking the pre-processing it, and by taking each text in the X test, right, and then actually we are vectorizing it. So these are the steps which we have done earlier as well. And now this Y predict, right, so this classifier.predict is the main evaluation part of it. Okay, so we are taking that complete transformed X test value, and we are actually predicting the we are actually evaluating is exactly like how the classifier will work. Okay, how well the classifier is able to predict based on the trained data, right? So you have actually trained the model by training your model with the training data. Now we are going to test the data. You have actually taken the test data, you have actually pre-processed it, you have actually transformed it, vectorized it, so made it into numbers and everything. So you have kept the test data ready. Now you are going to see whether that transformed data, when you are actually passing it to the classifier, will it be able to predict, okay, the right way as the classifier were doing it for the training data, right? So you are actually here simplifying, outputting the accuracy score. Just we are actually taking only the accuracy score. So here accuracy score is a function. Okay, so accuracy score is a function. For that you are actually passing the Y test. Okay, so this is the test data, so Y test and predict. Okay, so now when you print the accuracy, you will get something around 80%. So I mean, like, this model is actually not the best model, but it actually gives you almost 80.29% of accuracy. So this is how you have actually evaluate the model. So this is about the binomial naive Bayes. Okay, so we have seen two things. One is about the naive Bayes classifier from the text blob, and then this is the multinomial naive Bayes algorithm. Okay, so try different type of algorithms like this. Try to understand how the algorithm works. So it will be even more better if you understand how the algorithm works, and try to make your hands dirty. So all the best. If you have any doubts or anything like that, you can always get back to me. Thank you.